NENOMATICA, where mathematics meets YouTube excellence. Welcome to this mathematics tutorial, where we'll solve incomplete quadratic equations when the coefficient of x is 0. Let's start with an example. We'll solve the incomplete quadratic equation, ax squared plus bx plus c equals 0, when b equals 0. Step 1. Let's substitute b equals 0 into our original equation. This substitution is based on the zero coefficient substitution rule, which tells us that when a coefficient is 0, the corresponding term disappears from the equation. Step 2. We can simplify this equation by applying the additive identity rule. Since 0 plus anything equals that same thing, 0x simplifies to just 0. So our equation becomes ax squared plus c equals 0. Step 3. Now we need to isolate the x squared term. To do this, we'll subtract c from both sides of the equation. This gives us ax squared equals negative c. Step 4. Now we need to isolate x squared. We do this by dividing both sides of the equation by a. This gives us x squared equals negative c divided by a. Step 5. Finally, we take the square root of both sides to find x. Remember that when we take the square root, we get both the positive and negative values. So x equals plus or minus the square root of negative c over a. So our final answer is x equals plus or minus the square root of negative c over a. Whether these solutions are real or imaginary depends on the sign of negative c over a. It's important to note that for this solution to be real, the expression under the square root must be positive. This means negative c over must be greater than 0. This happens when a and c have opposite signs. If they have the same sign, the solutions will be imaginary. Let's look at our first example. We need to solve the equation 4x squared minus 16 equals 0. Let's solve this step by step following our algorithm. Step 1. We first isolate the terms with the variable on one side of the equation. In this case, for x squared equals 16. Step 2. We divide both sides by the coefficient of x squared, which is 4. This gives us x squared equals 4. Step 3. We take the square root of both sides. Remember that when we take the square root, we get both the positive and negative values. So x equals plus or minus 2. In the original equation, we can identify the coefficients. A equals positive 4 and c equals negative 16. Note that a and c have different signs, and the equation has two real solutions, x equals plus 2 or x equals minus 2. Let's move on to our second example. We need to solve the equation 2x squared plus 18 equals 0. Step 1. We first isolate the terms with the variable on one side. 2x squared equals negative 18. Step 2. We divide both sides by the coefficient of x squared, which is 2. This gives us x squared equals negative 9. In this equation, we can identify a equals positive 2 and c equals positive 18. Notice that a and c have the same sign. Since x squared equals negative 9, and there's no real number that, when squared, gives a negative result, this equation has no real solution. Let's visualize these equations graphically. For the first equation, 4x squared minus 16 equals 0. The parabola crosses the x-axis at x equals plus or minus 2. For the second equation, 2x squared plus 18 equals 0. The parabola never crosses the x-axis, indicating no real solutions. We need to solve the incomplete quadratic equation x squared minus 100 equals 0. Our first step is to isolate the x squared term by adding 100 to both sides of the equation. For the second step, we take the square root of both sides. Remember that when we take the square root, we need to consider both the positive and negative values. For our final step, we simplify the square root of 100, which equals 10. So our answer is x equals plus or minus 10. Now, let's move to our second example. We need to solve the equation 25y squared minus 3 equals 0. First, we isolate the y squared term by adding 3 to both sides of the equation. Next, we need to isolate y squared by dividing both sides by 25. Now, we take the square root of both sides, remembering to include both positive and negative values. We can simplify this expression. The square root of 3 divided by the square root of 25 equals the square root of 3 divided by 5. Let's start with our example. We'll solve the equation 5x squared minus 60 equals 20. Step 1. First, let's identify our equation in standard form. The standard form of a quadratic equation is ax squared plus bx plus c equals 0. In our case, b equals 0 since there's no x term. Step 2. Let's move all terms to one side of the equation to get the standard form. We'll subtract 20 from both sides. Step 3. Let's simplify the equation. Negative 60 minus 20 equals negative 80. So we have 5x squared minus 80 equals 0. Step 4. Now, let's isolate the x squared term. We'll add 80 to both sides of the equation. Step 5. Let's divide both sides by 5, which is the coefficient of x squared. This gives us x squared equals 80 divided by 5, which is 16. Step 6. Now, we'll apply the square root principle. If x squared equals 16, then x equals plus or minus the square root of 16, which is plus or minus 4. Therefore, the solutions to the equation 5x squared minus 60 equals 20 are x equals 4 and x equals negative 4. Let's verify our answer by substituting these values back into the original equation. We have the equation 2t minus 9 squared equals 5. The first step is to take the square root of both sides of the equation. When we take the square root of both sides, we need to remember that we get both the positive and negative values. Next, we solve for t by adding 9 to both sides of the equation. Now, we divide both sides by 2 to find t. We can rewrite this as t equals 9 over 2 plus or minus the square root of 5 over 2. Now, let's solve another quadratic equation. We have 2x squared minus 8 equals 0. This is an incomplete quadratic equation, as we only have the x squared term and a constant term, but no x term. Let's first rearrange this equation to isolate the x squared term. Next, we divide both sides by 2 to find x squared. Now, we take the square root of both sides. Remember, when we take the square root, we need to consider both the positive and negative values. We need to consider both the positive and negative values. Example, let's solve the equation. Negative 9x squared plus 27 equals 0. First, we need to isolate the x squared term. We'll move 27 to the right side of the equation. This gives us negative 9x squared equals negative 27. Now, we'll divide both sides by negative 9 to isolate x squared. So x squared equals negative 27 divided by negative 9, which simplifies to 3. Now, we take the square root of both sides. This gives us x equals plus or minus the square root of 3. So our solution is x equals plus or minus the square root of 3. Now, let's look at another example. Solve the equation 4x squared plus 16 equals 0. First, let's move the constant term to the right side of the equation. This gives us 4x squared equals negative 16. Now, we divide both sides by 4 to isolate x squared. So x squared equals negative 16 divided by 4, which simplifies to negative 4. Now, we need to take the square root of both sides. However, we have a problem. We can't take the square root of a negative number in the real number system. So we write x is not equal to plus or minus the square root of negative 4. This means the equation has no real solutions. A negative number under a square root is not defined in the real number system. Therefore, this equation has no real solutions. Why does this equation have no real solutions? This is because the number under the square root is negative. In the real number system, we cannot take the square root of a negative number. The reason for this is that a and c are not of opposite signs. In our second example, a equals 4 and c equals 16. Both are positive, so we end up with a negative value for x squared, which has no real solutions. We need to solve 3x squared minus 5 equals 70. First, we need to isolate the term with x squared on one side. We add 5 to both sides of the equation to get 3x squared equals 75. Next, we divide both sides by 3 to isolate x squared. This gives us x squared equals 75 divided by 3, which equals 25. Now, we take the square root of both sides. We get x equals plus or minus the square root of 25, which is plus or minus 5. Let's move on to our second example. We need to solve the equation left parenthesis x plus 1 right parenthesis squared minus 2x minus 2 equals 0. First, we need to expand the squared term. Using the formula for the square of a binomial, we get x squared plus 2x plus 1 minus 2x minus 2 equals 0. Next, we simplify by combining like terms. The 2x and negative 2x cancel out, leaving us with x squared minus 1 equals 0. Now, we isolate the x squared term. Adding 1 to both sides gives us x squared equals 1. Finally, we take the square root of both sides. This gives us x equals plus or minus 1. Let's summarize. Today we're going to solve this quadratic equation problem by following a step-by-step approach. Let's start by getting rid of the fractions. We'll multiply both sides of the equation by 24, which is the least common multiple of 8 and 12, to eliminate the denominators. Now, we'll distribute the multiplication by 24 to each term in the parentheses. For the first term, 24 divided by 8 equals 3. So we'll multiply the numerator by 3. For the second term, 24 divided by 12 equals 2, so we'll multiply the numerator by 2. Let's expand these expressions. 3 times 3x squared gives us 9x squared. 3 times negative 11 gives us negative 33. 2 times 74 gives us 148. And 2 times negative 2x squared gives us negative 4x squared. Now, let's combine like terms. 9x squared minus 4x squared gives us 5x squared. Negative 33 plus 148 gives us positive 115. Let's move all terms to one side by subtracting 115 from both sides of the equation. Now we divide both sides by 5 to isolate x squared. To solve for x, we take the square root of both sides. Remember that when we take the square root, we get both positive and negative values. Therefore, our final answer is x equals plus or minus 5. Let's verify our answer by Let's look at our example. We have the equation x over x plus 1 plus x over x plus 4 equals 1. The first step in solving this rational equation is to find a common denominator for the fractions on the left side. We'll apply the common denominator rule to rewrite the left side of the equation. Now we'll expand the numerator by distributing x in both terms. We'll apply the distributive property to simplify the expression. Next, we combine like terms in the numerator. We have x squared plus x squared, which is 2x squared. And we have 4x plus x, which is 5x. Now, to eliminate the fraction, we'll multiply both sides of the equation by the denominator. This is the multiplication property of equality. Let's rearrange the equation to get all terms on one side. We'll subtract x squared and 5x from both sides to get all terms on the left. Next, we simplify the left side by combining like terms. 2x squared minus x squared equals x squared, and 5x minus 5x equals 0. We can rearrange this to standard form. By adding 4 to both sides, we get x squared equals 4. To solve for x, we take the square root of both sides. Remember that when we take the square root, we get both the positive and negative values. Before we finalize our answer, we need to check if these values satisfy the domain restrictions of the original equation. The denominators in our original equation cannot be 0, so x cannot equal negative 1 or negative 4. Therefore, our final answer is x equals plus or minus 2. Let's summarize what we learned in this problem. We started with a rational equation and used common denominators to combine fractions. We then simplified the expression, moved all terms to one side, and solve the resulting quadratic equation to find our answer x equals plus or minus 2. This approach can be used to solve many other rational equations. Thanks for watching, where we'll learn about opposite roots in quadratic equations. We'll understand the conditions when a quadratic equation has roots that are opposite to each other, and solve some example problems to practice this concept. Let's begin by understanding what it means for a quadratic equation to have opposite roots. The condition for a quadratic equation in the form ax squared plus bx plus c equals 0 to have opposite roots is that b equals 0 and a and c have different signs. When we have opposite roots, if r is one root, then negative r is the other root. Let's understand this mathematically. When a quadratic equation has roots r and negative r, it can be factored as a times open parenthesis x minus r close parenthesis times open parenthesis x minus negative r close parenthesis, which simplifies to a times open parenthesis x minus r close parenthesis times open parenthesis x plus r close parenthesis, or a times open parenthesis x squared minus r squared close parenthesis, which equals ax squared minus a are squared. Comparing this with the standard form ax squared plus bx plus c equals 0, we can see that b equals 0 and c equals negative a are squared. Since a are squared is always positive for c to exist, a and c must have opposite signs. Now, let's solve our first example problem. For what value of m does the following quadratic equation have opposite roots? 3x squared plus open parenthesis, m squared minus 9 close parenthesis x plus m plus 2 equals 0. According to our condition, for a quadratic equation to have opposite roots, the coefficient of x must be 0. So we need m squared minus 9 equals 0. This gives us m squared equals 9, which means m equals plus or minus 3. Now, we also need to check the second condition. A and c must have different signs. Here, a equals 3, which is positive, and c equals m plus 2. If m equals 3, then c equals 3 plus 2, which is 5. Both a and c are positive, so they have the same sign. This means m equals 3 is not valid. If m equals negative 3, then c equals negative 3 plus 2, which is negative 1. Since it is positive and c is negative, they have different signs. Therefore, m equals negative 3 is our answer. Let's solve another example. For what value of m does the following quadratic equation have opposite roots? Open parenthesis, m squared plus 1 close parenthesis x squared plus open parenthesis, m squared minus 1 close parenthesis x plus m squared plus 3m minus 2 equals 0. Again, for a quadratic equation to have opposite roots, the coefficient of x must be 0. So we need m squared minus 1 equals 0. This gives us m squared equals 1, which means m equals plus or minus 1. Now, let's check the second condition. A and c must have different signs. Here, a equals m squared plus 1, which is always positive since m squared is always non-negative. And c equals m squared plus 3m minus 2. If m equals 1, then a equals 1 squared plus 1, which is 2 positive. And c equals 1 squared plus 3 times 1 minus 2, which is 1 plus 3 minus 2 equals 2 positive. Since both a and c are positive, they have the same sign. So m equals 1 is not valid. If m equals negative 1, then it equals 1 squared plus 1, which is 2 positive. And c equals 1 squared plus 3 times negative 1 minus 2, which is 1 minus 3 minus 2 equals negative 4 negative. Since it is positive and c is negative, they have different signs. Therefore, m equals negative 1 is our answer. Let's summarize what we've learned about quadratic equations with opposite roots. The condition for a quadratic equation, ax squared plus bx plus c equals 0 to have opposite roots is, first, b must equal 0. Second, a and c must have different signs. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.